Okay, good afternoon, everyone. Let's start the workshop. This workshop is particularly interesting for anyone which is in the process of implementing this ISO 19443 standard. And we will focus on three items embedded into the standard, which are extremely important in connection with establishing a robust safety culture. So let's keep the agenda and let's go straight to the point. So I think you are all familiar with the definition given by the International Atomic Energy on what is nuclear safety. So nuclear safety is what it takes to have in place operating conditions to prevent accidents, mitigate consequences, with the ultimate goal of the protection of workers, public environment for undue radiation risks. Now, this is, of course, embedding everything related to nuclear, but is this enough? Is this something which can itself prevent any bad consequences from radiation undue exposure for workers in the environment? And actually the answer is no. And this was basically something that in the development of the nuclear civil energy was experienced through accidents and through disasters, particularly starting from the 80s in several parts of the world, which came to the public, let's say, sensitivity through the Chernobyl disaster, where agencies started to formulate concepts related to safety culture. And safety culture is something that basically needs to permeate and embed as a core value whatever is done, is taught, and it is part of the feeling of people working in organizations which belongs to the supply chain of the nuclear energy. And there are more than one definition of safety culture. I brought on screen a couple of them. Many of them worldwide overlap in the concept. What is important to highlight on those definitions is that you cannot rely on policies, procedures, piece of paper specifying how to behave, what to do. You cannot rely only on leadership, which is of course super important for any safety culture, not only the nuclear one, but it is extremely, extremely fundamental to have individual commitments. And these individual commitments take shape through communication and through the, let's say, establishment of a feeling of freedom of people to speak up and out, addressing any concern related to nuclear safety. Why is that so important? It is important clearly, because of the prevention of accidents, okay? Undue spilling of radiations. And all the disasters that society experienced so far demonstrate, the criticality for that. But there's another element that I want to highlight, which is, again, relevant for the industry, which is the bad consequences related to the development of the nuclear technology and the bad image that this address. So the step backs that the industry experienced through experiencing incidents and disasters could have been prevented, and several thoughts relates to that conclusion, if an effective, functioning nuclear safety culture was in place. So it is not only to prevent damages to property, to people, to the environment, but it is extremely fundamental question on how to sustain and how to address the development of nuclear technology. Because again, everyone knows how volatile politics decisions are. I was listening this morning into the main hall, one of the keynote speakers, extremely convinced in the belief that nuclear is coming back, okay, because it is not polluting from the CO2 perspective emission, because it is a safe source of energy, and because it is also competitive. Again, I would put on top the fourth leg, which is if there's no an effective nuclear safety culture in all operations throughout the supply chain, this could be one of the risks that are not considered in the equation. Then this standard, which again is for the operators in the supply chain of nuclear energy, is specifying what does it take to have this safety culture in place. And it specifies requirements. And again, for any of you familiar with safety culture, no matter whatever it is, nuclear or whatever other industry, you clearly see all the components which takes to get implemented a safety culture. For the nuclear safety culture, of course, this is strictly connected to the nuclear risks, okay? So the risks related to undue exposure to radiations. And for the nuclear safety culture, one of the probably elements we can distinguish the nuclear safety culture from other type of safety cultures are the challenging unsafe acts. So employees should feel empowered, okay, to speak up and to address any perception of potential risks. All the other pillars are quite common and natural. The leadership commitment, in common with any other safety cultures. Balanced decision making, so conscious decisions on everything which could have an impact on safety culture, or on safety, nuclear safety, sorry. Transparency in communication, so nothing should get hidden and everything should be highlighted transparently. Documented information usage, that's normal, that's everywhere when we talk about safety. An effective reporting of issues, near misses and whatever concern potential threats to nuclear safety. And then, of course, learning from experience, another very common item. So let's start digging into the, let's say, hardware, the requirements of the standards which connect to the concept of the implementation of a nuclear safety culture, okay? So the nuclear safety culture is something high, super relevant. It has to permeate whatever it is done within an organization in the supply chain of nuclear power generation. Then let's look at the practical items which every employee working in an organization supplying nuclear energy should be aware of, should be trained about. ITNS. ITNS, important to nuclear safety. First of all, if you are not dealing with ITNS in your organization, for example, you cannot be certified against 19443. That's, I mean, let's say, it comes itself as an element for adopting the standard. Who is specifying what is an ITNS is the customer. The customer is specifying to the supplier. This is an ITNS product or service. Because if it fails, it could result in undue radiation exposure, okay? So the supplier needs to feel the commitment, but also the responsibility to look into this product, into this service, and how to deal about it. Then what needs to be done from the organization implementing 19443 is to break it down, okay? Look into the various item components, activities, and decide which of those elements composing the product or the service are actually ITNS. And we will see later some examples to get it more explicit. Not only, all the examples that will be shown during my presentation come from real-life experience of auditors, okay, dealing with real certified organizations. Then those critical items and activities need to be understood in terms of what is the way to deal with them. What is the risk assessment behind those items and activities in order to be in control for the prevention of the radiation risks. And again, quite normal for those kind of ISO-related management system standards, everything needs to be recorded and documented. So, what the organization to be certified needs to do is to hand over from the customer the specification of the ITNS, break it down, items, activities, and then decide which are actually important to nuclear safety, which are not. And each of them will, in the end, get affected by different level of risk management activities. So the second of the three important pillars, so another important element is with the acronyms of CFSI, which stands for counterfeit, fraudulent, and suspicious items. And if you remember what we have mentioned before, to have all employees motivated, trained, and with the right sensitivity on the suspect that something might get wrong, that something might fail, this is the clear connection on the topic. Because employees in the certified organization need to identify which are the counterfeit items, if any, fraudulent items, if any, or suspect items. So counterfeit items, the definition is self-explanatory, right? You have something which pretends to be something else. It pretends to be authentic, but it is not. It's a fake. Any single item components, okay? A screw. Fraudulent items are those which are falsified. And the falsification can also relate to the result of a test, okay? Or any other feature of maybe of an authentic item which is in reality not processed according to specifications. And suspect items is everything else which doesn't look right, okay? And which could introduce an, let's say, unexpected risk in the manufacture of the product or in the delivery of the service. So, it takes quite a complex thinking process to prevent CFSI to enter into the process before delivering items and products to customers. Super important is the control of the supply chain of the supplier. So selection of external providers is key. Controlling externally provided processes, products, and services. So which is the kind of control which is subject to those external providers. Specific information to external providers So specifications must be clear and there should not be room for interpretation. And of course, all the monitoring and measurement activities in terms of processes, specification, tools, but also competence and qualification for operators to perform the tests and the measurements. Okay? So if and when a CFS is identified, this is by definition a non-conformity following the requirements of the 19443. And as such, it has to be excluded from the manufacturing or process or service delivery until it is defined how to deal with it. The third pillar is the graded approach, meaning whatever we do to deal with ITNS needs to be appropriate. There must be, let's say, a judgment on the level of severity of tests, on the need of control and tests, on the robustness of the filter for any single steps or any single components of a product, which are appropriate to manage the nuclear risk. And how to do it? Of course, everything comes down from customer-specific requirements, where basically the level of quality checks on ITNS products must be specified and must be, let's say, handed over to the supplier. The complexity assessment of the product which has to be manufactured or the service which has to be delivered, which results in the appropriate answer, and examples are coming, and also organizational factors. So, which are the conditions and the characteristics of the organization in order to perform specific tasks which could affect the severity of those controls and the way those controls can be considered appropriate or not to prevent the risk. Documentation and records, of course, comes themselves. And this is quite a common table which is available in the standards, basically representing an example of what it is, the graded approach, but also what it is, the breakdown in items of an ITNS. Because if the ITNS is a pump, the handle of the pump or the sealing of a connector are two completely different animals. Maybe the handle is not important to nuclear safety. Certainly, the sealing is. So the level of quality requirements, the severity of the tests, the type of records which have to be maintained, the documentation of what needs to be done, the qualification of people which needs to take care of the different components shall be different. And the difference, which is then captured into the graded approach, can also make the difference from a supplier to make money out of this pump production or to lose money. Because if you overdo, you introduce unnecessary elements of cost. If you undo, you save money, but you take risks for nuclear safety. So this is the concept behind those three key elements of 19443. And then we want to make it even more explicit for you through some case studies collected from daily auditing activities. Customer is asking to install a scaffolding urgently for yesterday. Should manager say, let's rush and deliver it? Or should manager say, hang on, we need to do a risk analysis, what this scaffolding is used for? And of course, the second one is the right answer. Okay? It could have an interference with positioning or collecting ITNS components, So it is not safe for nuclear safety to rush on the delivery of that customer urgent request. Another one relates to CFS product. If a person is usually performing the validation of a product, and this person is vacant, he is on vacation, it's, I don't know, his birthday. Can another one, maybe a colleague, okay, working with him or in the same department, can do the job, can do the validation, signing on behalf? Or should we wait for that person to be back? And the correct answer is that if that person is designated to perform the validation, then that person must do the validation, no matter how and what. And even though the colleague was there and the colleague is smart and the colleague will sign on behalf, this is not acceptable. This is a non-conformity. Again, the safety culture. If something can go wrong, it might get wrong, and no margin for tolerance at risk-taking attitudes. A product is under a test, a measurement test. The specification is 10 centimeters plus minus 0.10, 2 digits. The result of the test is 0.14 centimeter. And the operator writes 0.10.1. So 1 digit only. Was it 14? Was it 17? Was it 10 after the comma? This is considered fraudulent. Okay? Because the product might be good, but we don't know, because it's not compliant with the specification for the measurement. A person has been hired at the reception of a good. They need to be trained to know which are the ITNS and the graded approach and get the checklist to focus on, or only the technical function can do the job. Actually, it is not only a specific technical function to be knowledgeable about the ITNS of a company. Because which are the ITNS you deal with in the company that is certified against 19443? This is a common knowledge. Even walls needs to smell and to know which are the ITNS you work with. We manufacture valves. You need to break down in which part my valve is an ITNS or the whole valve is ITNS. And again, this is something that we already saw in previous slides. You have to do the breakdown. This is a requirement by the standard, because different components of the valve can have different risk profile. Conclusions. How to demonstrate that there's a strong safety culture during an audit? Basically, everything cooks down from the answer you could expect from your employees. All employees, no matter their role in the organization. Do they know the ITNS they work with? If the answer is no, then that's not good. What precaution do I take when working on an ITNS? They need to know, everyone. How can I identify or be alerted on potential counterfeit CFS products in general, suspicious, fraudulent? Everyone needs to know. How do I take into account the elements? Then you read the others. Super important. Training. All people need to be trained. And one of the elements of training is that they need to feel empowered and encouraged, also through internal surveys, to speak up and challenge unsafe actions. They need to be free to go to their supervisor or to their line manager saying, I don't feel safe doing that. You are asking me to do that. I think this is a wrong procedure. I don't feel safe. This might trigger a risk. That being said, couple of slides. This is statistics coming from our audits, which is the intensity of findings corresponding to the chapters of the standards. As you can see, most of them relates to the chapters related to operations. But there's a trick behind, because in most of cases, findings or non-conformities, deviation from conformity, depends on the chapter 6, which is the one related to the design of the system and to the identification of ITNS in general, so the risk assessment part. And I think the time is over. Thank you. Credits to Francois Cosanel, our technical expert, in preparing this workshop. I hope it was interesting. We can address your questions then in the small room. Thank you very much.